Good evening, viewers, and welcome to Geology News Today, your source for the most rockin' news on the planet. I'm Glinda Gabbro. Tonight, in our main story, we will have reporter Betty Basalt joining us to report on the megathrust earthquake, which occurred in the Cascadia Range this morning at 11:30 a.m.
I'm Betty Basalt reporting to you live from Geology News Today's in-house newsroom. This morning at 11:30 a.m., a megathrust earthquake occurred off the coast of Washington State along the Cascadia subduction zone in the Pacific Ocean floor. For our viewers at home less well-versed in geologic terms, megathrust earthquakes are great earthquakes, those with a magnitude of 8 or more, and are rare events that can cause tremendous loss of life as well as material and economic damage. These earthquakes occur at subduction zones with shallow dip angles of 45 degrees or less. The contact surfaces between the two converging plates are known as megathrust faults. These faults typically run from the ocean floor under the margins of continents. Lying underwater introduces a subsequent hazard, that of tsunamis. The last megathrust earthquake in the Cascadia subduction zone, where the Juan de Fuca plate and the North American plate interact, was in 1700 and had a moment magnitude of 8.2 to 9.0. Recent findings have shown that the Cascadia subduction zone is much more volatile than originally thought. The constant friction of the plate boundaries results in a lot of accumulated stress. Knowing that megathrust earthquakes occur approximately every 300 to 1,000 years, we were almost or starting to be overdue for an event of this magnitude. We have yet to see the more far-reaching effects of the megathrust earthquake today. However, we can use the effects of the Sumatran earthquake in December of 2004 to predict the fallout. The chief consequence of the Sumatran earthquake was a deadly series of tsunamis. More than 200,000 people died in more than 14 countries as a result. Local buildings were not strong enough to remain fortified, and there was a partial or total destruction of many properties. So far, it is clear many people have died and many buildings have been destroyed from powerful aftershocks along Washington's coast. We can only hope that the inevitable tsunami caused by this earthquake underwater does not result in as great a loss of life as the Sumatran earthquake. Back to you, Glinda.
Thank you, Betty, for that in-depth reporting. Our thoughts go out to everyone in the quake zone today. Now we're going to return to our scheduled news programming, choosing your granite countertop, the best quartz to muscovite ratio. Oh my, I've received word from our Hawaii Bureau that the megathrust earthquake has caused a tsunami that has hit the island of Hawaii.
Thank you, Glinda. I'm Shelley Shale, reporting on the tsunami that just struck Hawaii. Hundreds may be dead. For our viewers at home, a tsunami is a series of ocean waves that send surges of water inland. Survivors reported seeing drawback, meaning the water receded quickly from the beach. Many knew this was a warning sign of tsunamis and ran inland toward higher ground. Unfortunately, many did not see it soon enough. Tsunamis can travel up to 600 miles per hour, and from a distance they do not appear to be large. Out at sea, tsunamis only reach up to a height of 1 meter because they form underwater, so it is hard to predict when a tsunami is approaching. As a tsunami wave approaches the coast, the trough, or bottom of the wave, hits the ocean floor, causing the wave to slow down, increase in height, and to decrease in wavelength. At landfall, a tsunami wave can be hundreds of meters tall, with steeper shorelines producing higher tsunami waves. In addition to these large tsunami waves that crash onto shore, the waves push a large amount of water onto the shore above the regular sea level, called runoff. The runoff can cause tremendous damage inland and is much more common than huge thundering tsunami waves. It is reported that this tsunami that struck Hawaii was caused by a 9.0 magnitude earthquake in the Pacific Ocean near the northwestern United States. The majority of tsunamis are caused by undersea earthquakes at tectonic plate boundaries, and 80 to 90% of all tsunamis occur in the Pacific Ocean's Ring of Fire, because it is a very geologically active area. The Ring of Fire circles the ocean from Alaska down the west coast of North and South America and up along the east coast of Asia, taking in parts of China, Japan, and Russia. When underwater earthquakes occur, huge amounts of energy are released, as a result of quick upward bottom movement. A large earthquake can lift thousands of square kilometers of seafloor, which will cause the formation of huge waves. Even though tsunamis are most commonly caused by underwater earthquakes, they are also formed as a result of underwater volcanic eruptions, underwater landslides, and even large meteorites plunging into the ocean. This tsunami that struck Hawaii was not the only one recently. On December 26, 2004, the deadliest tsunami in history struck, killing over 200,000 people. It affected 11 countries, including Sri Lanka, Thailand, and India. It was caused by a 9.0 magnitude earthquake under the Indian Ocean near the west coast of Sumatra. This is the largest earthquake that has been recorded worldwide in the past 40 years. Pressure built up until an earthquake was caused due to the Indian plate sliding under the Burma plate. It is estimated to have released energy of 23,000 Hiroshima-type atomic bombs. The earthquake caused a rupture 600 miles long and displaced the seafloor by 10 yards horizontally and several yards vertically, which displaced the water. This was a massive disaster that had many effects. Hopefully, people are safe in Hawaii.
Wow, thank you, Shelley. It has been a wild day in the world of geology. On a lighter note, it's time for our poll of the day. Today's topic, pet rock breeds. Do you prefer igneous, metamorphic, or sedimentary? Breaking news. Special correspondent and resident rock star Rick Lieberman is reporting live from the field where the unthinkable has happened. The Yellowstone supervolcano has erupted.
Hi, Glinda. Coming to you live from Yellowstone Park, where the supervolcano explosion of the caldera is rocking both the nation and the world. Calderas are ultrafelsic volcanoes which do not take either a composite or a cone shape, but, as is the case with Yellowstone, a large ring basin. The magma beneath the caldera is very close to the surface, creating the distinctive hot springs and geysers of the park. The last eruption, 650,000 years ago, and a VEI, or Volcanic Explosivity Index of 8, created the current 50 by 70 kilometer caldera, and it is estimated that the pyroclastic flow, including ash, pumice, and welded tuff from this explosion, will cover approximately 3,000 square miles. Such byproducts, which are 6 times heavier than snow, will ground planes, halt communication, and collapse buildings. Additionally, the economy will likely face disaster. The volcano eruption in Iceland in 2010, a VEI of 4, cost the airline industry approximately $158 million and disrupted flight patterns for weeks. Less recently, when Mount Tambora in Indonesia erupted in 1815, it created a year without summer. The northern hemisphere suffered massive food shortages and the global temperature cooled dramatically. Though at the time, VEI 7 on the Volcanic Explosivity Index, it was the largest volcanic eruption in recorded history, but it has now been eclipsed by the Yellowstone caldera, which will absolutely be a VEI 8 or more. And now we go to a press conference live with me, Rick Lieberman.